Hello students, this video is on section 2.3, equivalent fractions. You may know that some fractions with the same value can look different ways. A very common example of that is 1/2. A lot of people are familiar with the fact that 1/2 can be written with the same value by saying 2/4 or 3/6 or 4/8. We can continue this on forever. There is an infinite number of fractions that have the same value as 1/2 but look different. It can be useful to rewrite fractions in different ways. Remember that the denominator of a fraction tells us the size of the piece by telling us how many parts one complete thing is cut into or divided into. In order to compare or combine fractions, we need to be talking about the same size pieces. So an example of how we would find equivalent fractions is as follows. If I have the fraction 1/3, as a diagram that could look like this. I have a rectangle and I'm going to divide it into 3 equal parts. That's the denominator. And I'm going to take one of those equal parts. That's coming from the numerator. But let's say instead of thirds, I need to be looking at something with a total of 6 pieces in it. So what we're saying is how many sixths are in 1/3? Okay? So I'm not going to change the diagram much. But what I do need to know is that now there's going to be 6 equal pieces instead of 3 equal pieces in my diagram. I can do that by simply drawing a line like that. I now have 6 equivalent sized pieces in my diagram. And what I'm going to do, the 6 has become where the 3 was, or has become the part that the 3 was. We've divided each of the 3 parts into 2 individuals, which gives us 6 total. And then I'm going to count, I have 1, 2 parts that are shaded. So I haven't changed the value of my fraction, I've just changed what my fraction looks like. The 2 comes from splitting the single piece that was shaded into 2 equal pieces. Okay? If you notice in our next example, there will be a faster way than drawing a diagram. So our next example is 3/4 or 3/4. And this diagram, you can draw any shape, any size, anything, as long as we are talking about a single whole thing divided into equal pieces. So I have a very large triangle and I'm going to divide it into 4 equal pieces, like that. Okay, so I have 4 equal pieces here. I'm going to shade 3 of them in. There's 1 of them, there's 2 of them, and there's 3 of them. Okay, so I have shaded 3/4 of this, and I want to know how many 16ths are in 3/4. Okay, so I'm going to write my equivalent fraction to begin with. I know I'm looking for 16ths. How many 16ths are there in 3/4? So what am I going to do if I had 4 pieces and now I need 16 pieces? So I'm going to divide each of the 4 pieces into 4 of its own pieces. Okay, so these are all equivalent pieces now. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've split each of the 4 pieces into 4 individual pieces to get 16. Now I need to count how many are shaded at this point. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of the 16 pieces are shaded. I haven't changed the shading All I've done is change the size of the pieces that we're looking at. So at this point, you might be able to see a pattern. With 3 to 6, what I did was I split each part into 2 parts. So 3 times 2 became the 6, and the single part that was shaded was also split in half in that process, so it became 2 of the parts. 1 times 2 is 2. The same thing is happening here. We started with 3/4 or 3/4. I had to split each of the quarters into 4 more pieces, so 4 times 4 is the 16, and then each of the 3 pieces that were shaded were split into 4 as well, so 3 times 4 is 12. I'm going to do one more example showing you this way, and then we'll do it purely mathematically using multiplication instead. Okay? So the last fraction that we'll do is 2/5. So here's my whole. I'm going to split it into 5 equal parts. And I'm going to shade 2 of them. Doesn't matter which 2 I shade because they are all equal. And I'm curious as to how many 15ths there are in 2/5. Now, using what we just talked about, you might be able to figure that out, but I'll show you again. In order to have 15 equal pieces, I'm going to have to split each one of these 5 into 3 pieces. So where there was 1, now there's 1, 2, 3. Okay? Going to do the same thing with all of them. Okay, so now I have 15 pieces, and how many of those 15 are shaded still? I haven't changed the shading, I've just changed the size of the pieces. So I have 1, 2, 3, 4, 5, 6. So there are 6 15ths in 2/5. They are the same size, they just look different. So if you were able to do that before I drew out the diagram, you would have been able to say, since we're looking for 15ths, I'm going to multiply by 3. And with a fraction, in order for the fraction to stay equivalent, we need to change the top in the same way we change the bottom. So because I knew to multiply by 3 to get 15, and I was looking for the new numerator, I'm going to multiply by 3 again. 2 times 3 gives 6. Okay? Without drawing a picture, if I have 1/9, and I want to know how many 18ths that is, I can say, what times 9 gives me 18? Well, I'm going to multiply by 2, and I'll do the same thing then on the top. So that gives me 18, which is what I needed. The problem would give that to you. And then on the top, we would do times 2 to find 2. So 1/9 is equivalent to 2/18. And you can do this if they give you the top number as well. Whatever they did to the top number, whatever they multiplied by, you would do the same to the bottom numbers or denominators. So I'd like for you to try these 2 problems. Once I write them, pause the video, try them, and then come back and I will show you the answers. So 1/7 is equivalent to how many 28ths? Is your first one. The second one I'd like you to try is 3/10 is equivalent to 24 over what? Go ahead and pause the video. Try those out. Okay, for the first one, you should have gotten 4 on top, 4 28ths. And for the second one, you should have gotten 80 on the bottom, 24 over 80. All right, any questions you have, please make a note of them, and we will talk about that in class.